Okay, today we'll be looking at the answers to our test review. Test is Thursday. All right, so the first one says if net force equals 0, what will happen? If your net force is 0, then we are in what we call equilibrium. Get this thing set first. And so this means we are in equilibrium. That means all forces exactly counteract each other. If net force equals 0, there is no acceleration, and therefore we'll have no change to our motion. It will not change its speed. It will not change its direction. So A, B, and C are incorrect, so D is the answer. If A equals 0, same scenario we just had, then the object is in equilibrium. The object will not change its speed or direction, and net force equals 0. The answer is all of the above. If you apply a force to the right, okay, if you have an object and you apply a force to the right, the object will accelerate to the right. But if the object is already moving to the left and you apply a force to the right, then it will slow down. So the object must slow down if going left or speed up if going right. Which of Newton's laws describe why a roller skater rolls away from a wall to the left when she pushes to the right? So if you've got someone on skates, and they push against a wall, the wall pushes back, and the person will roll away backwards. And this is Newton's third law. For every action, there's an equal and opposite reaction. So we say action, reaction. Newton's first law says that an object will keep moving unless an outside unbalanced force acts on it. What force constantly works against an object's motion? It is not gravity, it is friction. And this comes down to this one: friction can only oppose or resist or slow down. Okay? Can only oppose the direction of motion, resist the motion of direction. So if you're moving one way, friction's always the opposite way. What force caused a 35 kilogram object to accelerate at 7.09? F equals ma. 35 times 7.09. And I can't remember the answer to this one. 35 times 7.09 equals 248. It's 248. Forgot to change this from our previous worksheet. John drops the following items through a set of photo gates. Item number 3 is way off. The photo gate is very precise and accurate, so why is number 3 so far off from the other? So here's our trials. Trial 1, it only takes 1.25 seconds for it to go through. 2 of them takes 1.27. Number 3, 3.52. So why is number 3 so far off? So something stopped the object for a moment as it fell. Okay, since the time here is bigger, and this is probably what happened. It probably got stuck in there for just a second, then fell through the object instead of dropping it. If your time had been more something like 0.50 seconds, then he might have thrown it because it's going faster as it goes through the photo gate. John probably moved the photo gates closer together. So that wouldn't be it, because as it goes through the photo gates, it would get, if they got closer together, the time to go between one set to the other would be smaller. So probably something stopped it as it fell, since the number is bigger. Sergio has a mass of 75 and sits in his chair. What's the normal force on the chair? The normal force is going to be equal to the weight. So that's mass times gravity. So that's 75 times 9.8. And 75 times 9.8 is 735 newtons. A 5 Newton force left is opposed by a 50 Newton force right. What additional force would make this equilibrium? To be equilibrium, you want the left side to equal the right side. So what plus would equal 50? The answer is we'd have to have 45 to the left, so we'd choose C. 45 to the left plus 5 to the left gives us 50 total. A 55 kilogram soapbox derby car rolls down a hill going from 0 to 23 in 3.9 seconds. Calculate the net force. The hint here is you must solve for acceleration. So we plug in for acceleration first, Vf minus Vi over T. Remember, you have to use parentheses. 23 is your final speed, so 23 minus 0 divided by 3.9. That gives us 5.90. And we multiply that times the mass of the car, 55. We get somewhere around 324 newtons. That's the force acting on the car to cause it to accelerate. What net force acts on a 38 kilogram object that has a force of 153 to the right and is being resisted by 3.2 newtons? All right, so net force is going to equal 153 to the right plus 3.2 to the left. When things are going opposite directions, you subtract them. So it's 153 minus 3.2, and that gives you 149.8 newtons to the right. Draw a free body diagram of a 12 kilogram object on a table that has a force of 20 newtons to the right, being slowed by a 4 Newton friction force. Our box on the table, we have gravity pulling it down. Fg equals mg equals 12 times 9.8. And that's 118 newtons. Because we're on a table and we're not falling through the table, that means the table has to push up with a normal force that's equal to the Fg, which is 118 newtons. We have a force to the right of 20 newtons. We're being resisted by 4 newtons. So our F net is 20 to the right plus 4 to the left. Going opposite directions means subtract. So we have 16 newtons to the right as our net force. Our acceleration will be F net over mass. So 16 over 12, which is 1.33. To the right. What would the acceleration of a 60 kilogram object being pushed with a force of 40 newtons on a frictionless table? Okay, our formula says, we rearrange it, A equals F over M. So 40 divided by 60 gives you 0.67 meters per second squared. And it doesn't tell us what direction, so we don't have a direction here. A frog sits on the bank of a pond. Princess, the world's cutest dachshund, tries to catch the frog. If the frog has a mass of 0.34 kilograms and it applies a force of 3.83 newtons, at what acceleration will it leap to safety? So you've got a frog, and it will apply a force of 0.3. It'll apply that force backwards. You don't have to draw a picture. Against the ground. So the acceleration will be F over M. And that gives you 11.26 meters per second squared. And that acceleration will be up. So he leaps, so that means he's going up into the air. So what happens here is, what's the action-reaction force pair for the frog leaping? So the frog pushes down, and I'm going to put it a little sideways there, against the ground. So you have a force down of 3.83 newtons. And then the ground is going to push back up with 3.83 newtons. And so the frog, being very light, springs up into the air and away, and the ground being very heavy doesn't really do anything. So A is the action-reaction pair. Frog pushes on the ground pushes on the frog. You cannot push on gravity. Gravity isn't a corporeal. It doesn't have a body to it. 17, a man runs a 3,500 meters east and then runs 4,500 meters south. Determine his displacement. So you've got a vector problem. So we're going to use C equals the square root, 3,500 squared plus 4,500 squared. So you put that in your calculator. And that will come up to 5,701 meters southeast. A 100 kilogram man runs into a 65 kilogram woman and knocks her down. Which of the following is true? The man applies more force to the woman than the woman applies to the man. The woman applies more force to the man than the man applies to the woman. They each apply the same force to each other according to Newton's third law. Well, obviously we said Newton's third law, so there you go. It's got to be C. You can't hit anyone any harder than they hit you back. What is the mass of a car that is propelled to the right with an acceleration of 3.75 meters per second squared if the force applied was 3,950? Mass equals force over acceleration. And that is 3,950 over 3.75. And that gives us 1,053 kilograms as my mass. If a net force is applied to the object, what must happen? Okay, so if a net force is applied to any object, no matter what object, then the object must change speed or change direction, or both. If a net force is not zero, the net force is not zero, that means a net force is applied. That means you have to change your speed or direction. There must be a change in velocity. That's really all that we're covering. So good luck.